Hi everyone, so I thought I would just make this video as a recap for what we did in the first test work. So if you remember, this table is used to explain or show the delivery of an emitter and then various emitters in a field. So you've got your lateral lines. So this specific one shows 5 lateral lines like this, and then 5 emitters per lateral. So this is what it represents. And for every single emitter, we have a rate at which the water is leaving the emitter. So because we don't always have exactly the same amount of water leaving every single emitter, so it's not always perfect, and over time, if you have problems with your emitters, those emitters can get worse. So in order for us to correctly determine when to replace those emitters, we can check the rate at which the water leaves the emitter, and if we have a variation in our field that's larger than 10%, that means that some of the emitters need to be replaced. So that's why we have a table like this, and all of these values are values that we got from measuring the rate at which the water leaves the emitter. So you can maybe just trust me on this one, but if we add all of this together, we get a total of 56.58 liters per hour. So that's when we add every single one of these together. And now we want to get an average. So for all 25 of these emitters, we want to get an average for the rate at which the water is leaving the emitter. So we'll take that 56.58 divided between 25, so that's the 25 emitters, and then we have 2.26 liters per hour as our average. So let's look at our maximum. So for this, you just need to search in the table and see what is the largest value. And so the largest value in this table is that 2.52 liters per hour, and the minimum is 2.04 liters per hour. So that was the smallest value in this table. So the last thing we want to calculate is this percentage delivery variation. And in order for us to calculate this, we take the maximum value, which is this one. So that's at 2.52. We minus 2.04, which is the smallest one, and we divide it by the average. So that's 2.26. And then we multiply that by 100. And what we get is we get 21 or 0.2, but if we multiply that by 100, we'll get roughly 21%. And so because this value is larger than 10%, so the amount of percentage variation in this block is larger than 10%, that means that we need to find, we need to replace some of these emitters or the laterals, and therefore we'll say replace some of the laterals. And that is the calculations with regards to emitters and emitter delivery.